Hi everyone, I'm Mrs. Fitzpatrick, and today we are going to be working on a lesson 6.4, and it's on factoring polynomials. So a lot of what we're going to do today is going to feel like review, but it's all to get us prepped for actually solving polynomials for their zeros, and that's going to require us to be able to factor them completely. Okay, so the first thing is we're going to review finding a GCF, which stands for greatest common factor. So what we're going to do is I'm going to do all of the odd problems, and then I'm going to have you pause the video to do the even problems within each section. Okay, so looking at the first section, we have greatest common factor. Let's go ahead and look at example 1. I have 12a cubed plus 10a squared. So I'm looking first at the numbers 12 and 10. And I notice that they both have a common factor of 2. So I'm going to go ahead and pull out a 2. Then I'm looking at a to the third and a squared. And I notice they both have an a squared in common. So I'm also going to pull out an a squared. And then I'm going to write what's left in parentheses. So I have 6, because 12 divided by 2 is 6. A cubed divided by a squared is a, plus 10 divided by 2 is 5. A squared divided by a squared is just 1. So this factors to 2a squared times 6a plus 5. Notice I didn't actually change the value of any of these numbers, because if you distribute back in that 2a squared, you end up back where you started. So we're simply rewriting it in factored form. Okay. Next, I'd like you to pause here and go ahead and do number 2, and then we're going to move on to perfect squares. So we have another factoring method whenever there's a difference of squares, but it's a good idea first to remember your perfect squares. So let's go ahead and write a few of them down. 1 squared would be 1, 2 squared 4, 3 squared 9, 4 squared 16, 5 squared 25, right? We have 36, we have 49, 64, and we could keep going on and on, right? So just as a refresher, those are our perfect squares. A perfect square is just any whole number squared. Okay, let's take a look at the rule for difference of squares. If you have something in the form a squared minus b squared, it factors to a plus b times a minus b. All right, so let's take a look at the examples. We're going to do 3 and 5 together, and then I'm going to have you do numbers 4 and 6. Okay, let's take a look at number 3. I have 9x squared minus 49y squared. So I'm looking and I notice that 9 is a perfect square, and same with 49. So first, I'm going to rewrite 9x squared as 3x quantity squared. Notice now I have something squared. Minus, I'm going to rewrite 49y squared as 7y quantity squared. Notice if you square that, it's still 49y squared. So using our rule, this just factors to 3x minus 7y times 3x plus 7y. And that is it. All right, let's go ahead and try number 5. So one thing we didn't do, or I didn't mention, is you always want to start by looking for a GCF. Looking at 9x squared and 49y squared, there really wasn't anything we could pull out, but in number 5, there is. So you always, regardless of the method you think you should use, always start by looking for a GCF. So looking at 7 and 28, looks like they actually do have a common factor of 7. So I'm going to go ahead and pull that out. Now, looking here, I have m to the 7th in this term, and m here. It looks like I can also pull out an m. They also have the variable n in common. They have n and n cubed, so I can also pull out an n. Now I'm going to go ahead and write what's left. So m to the 7th is the only term that's going to, the m term is the only one that's going to be left. So m to the 7th divided by m, we're just left with m to the 6th. minus 7 times 4 is 28, so 4. M over m is 1. N cubed divided by n is n squared. Okay, so now we're going to use our difference of squares rule to factor what's in the parentheses. So I have 7mn times, now this is a little bit tricky. We need to rewrite m to the 6th as m to the something squared. Well, we can rewrite this as m cubed squared, because when you raise an exponent to a power, you multiply. Minus, we can rewrite 4n squared as 2n quantity squared. All right, from here, we can just use our rule. So 7mn, times, we get m cubed minus 2n times m cubed plus 2n. And that is as far as we can go for now. Okay, so go ahead and pause here and try numbers 4 and 6 on your own. Okay, the next little refresher we're going to do is how to factor trinomials. Now, remember, just because they're trinomials, we do not want to forget to always first look for the GCF. So much of this should be review from previous units. The only one that might look a little bit funny would be like number 15 and maybe 18, but 18 is going to actually be really similar to 15. So we're going to do 15, 17, and 19 together, and then use that strategy for numbers 16, 18, and 20. Okay. So we have a trinomial in number 15. Now this one looks tricky, but let's just do a little bit of a substitution to make this look like a quadratic. Okay, so here's a little trick we're going to play. We can rewrite n to the 4th as n squared squared, okay? So it's n squared squared, 2 times 2 is 4, right? Plus, let's think of this as 2 parentheses n squared minus 24. Now, let's let n squared equal, let's just call it a. So we end up with a squared plus 2a minus 24. Well, now this looks just like a quadratic. So what are two numbers that multiply to negative 24 and add to 2? Well, we could use positive 6, right, and negative 4. So this factors to a plus 6 times a minus 4. And then from there, we just sub back in n for a. So it is n squared plus 6 times n squared minus 4. Now you might notice something. We can actually keep factoring that n squared minus 4. It's a difference of squares. So let's go ahead and go one step further. We can't right now factor the n squared plus 6. That one's not a difference of squares, so we're going to leave it. But n squared minus 4 factors to n minus 2 times n plus 2. And that will be as far as we can go for now. Okay, let's go ahead and jump into number 17. So remember, we always want to look for a GCF first, and this one definitely has one. So it looks like we can pull out a 2 and an a here. And then what we have left is a squared plus 38 divided by 2, we get 19a plus 68 divided by 2, we get 34. Okay, now I'm looking for two numbers that multiply to 34 and add to 19. We have 17 and 2, right? So this just factors to 2a times a plus 17 times a plus 2. And that's as far as we can go for this one. Okay, we have one more left in this section. So number 19, we have 3x to the 4th plus 14x squared minus 5. Now this one looks very similar to number 15, right? We have a 4th degree and a squared. And so let's go ahead and do the same thing and rewrite that using our little trick. So we're going to let x squared equal a. So I can rewrite this as 3x squared squared plus 14 parentheses x squared minus 5. Now, anywhere I see an x squared, I'm going to go ahead and replace that with a. So we end up with 3a squared plus 14a minus 5. Well, there's no GCF here, so we're going to have to use slip and slide, if you guys remember that method. So let's go ahead and start with the slip. So we steal the 3, give it to the 5. So we end up with a squared plus 14a minus, we're going to multiply. 3 times 5 is 15. Now, we're going to find two numbers that multiply to negative 15 and add to positive 14. So 15 and negative 1 are going to work here. So we have a plus 15 times a minus 1. Well, we stole the 3, so now we have to take it back. So I'm going to divide by 3. Now you reduce if you can, so a plus 15 over 3 is 5. And then if you can't, and there's still something in the denominator after reducing, you slide. So then it's times 3a minus 1. Well, the last step is we have to sub back that x squared in for a. So this would be x squared plus 5, which we can't factor that any further, times 3x squared minus 1. And that we're not going to factor any further either. So that is as far as we can go. Okay, using those same methods, go ahead and try 16, 18, and 20 on your own. All right, so the next section that we are going to be looking at are when you have 4 terms, we're going to learn a new factoring method called grouping. So using this example up here, when there's 4 terms, what you can do is group the first 2 terms and the last 2 terms together, just like that. Now, pull out the GCF between the groups. So x cubed and x squared, they have a GCF of x squared. And I'm going to go ahead and write down what's left. X cubed over x squared is just x, plus x squared over x squared is 1. Between the negative 4x and minus 4, they have a GCF of minus 4. And then parentheses, I'm going to write what's left. Negative 4x, take away the negative 4, you just have x. Negative 4 over negative 4 is plus 1. Now notice here that they have an x plus 1 in common. If that's the case, we can actually factor out the x plus 1 from the x squared and the minus 4. So this factors to x plus 1 times x squared minus 4. Well, that actually factors one more time because that's a difference of squares. So our final answer here would be x plus 1, and then x squared minus 4 factors to x minus 2 times x plus 2 to factor completely. Okay, so let's do a couple more examples of grouping. Let's go ahead and try numbers 21 and 23. You're going to do 22 and 24 on your own. All right, so number 21, we always start by grouping the first 2 terms and the last 2 terms. We're going to factor out the GCF, so x cubed and x squared, they have a GCF of x squared. I'm left with x minus 1, and then 9x and 9 have a GCF of 9. So plus, we're going to pull out a 9, and then we're left with an x minus 1. Well, now they have a common factor of x minus 1. So from there, I'm going to go ahead and factor out the x minus 1, and then it's x squared plus 9. And that's as far as we can go. That's not a difference of squares, that's a sum of squares. We don't have a rule for that one, so we're going to stop there. All right, let's do one more factoring by grouping, and then you're on your own. All right, so this one, once again, we're going to group the first 2 terms, which are 4v cubed minus 5v squared. We're also going to group 16v and 20. Okay, so real quick, be careful with that negative. I'm actually going to lump it in there because when you factor out whatever you're factoring from the first term, you want to factor a negative number out. I'll show you why in a second. Okay, so 4v cubed and 5v squared, we can pull out a v squared times, we're left with 4v minus 5. Now I'm going to pull out between 16 and 20, I'm going to pull out a minus 4 because I want that guy to be actually negative, so it matches that. Okay, so we're going to pull out a minus 4 times negative 4. When I pulled out of negative 16, I'm left with 4v. 20 over negative 4 is minus 5. Notice now we have that common factor of 4v minus 5. All right, so I'm going to pull that out. We have 4v minus 5 times v squared minus 4. But I'm noticing I have a difference of squares, so I can go one more step. This factors to 4v minus 5 times v minus 2 times v plus 2. And that is the final answer. All right, go ahead and pause this and do numbers 22 and 24, and then we're going to fill in this factoring guide. Okay, so this is your little guide to factoring and making sure that you try all the proper methods before you jump into something that is a little bit more intensive, or to always remember just to use a GCF first if you can. So first, always check for a GCF. If a GCF worked, you stop. You don't want to keep going. And sometimes you have to keep going after the GCF, but if you have an example like this, where you have, so example, 2x squared minus 16x, and we're factoring, when we pull out the 2x, we have x minus 8 left, and we actually can't go any further. So if the GCF worked, you're done. But if you have a GCF and then you're left with a difference of squares, or you're left with a trinomial, or 4 terms for grouping, that's when you should keep going. All right, so if GCF wasn't enough, then maybe you have a difference of squares. And remember, difference of squares looks like a squared minus b squared, which would factor to a plus b times a minus b. So for example, if you have x squared minus 9, that would factor to x minus 3 times x plus 3. Okay, you may have a trinomial where a equals 1, and if that's the case, it will look like x squared plus bx plus c. Okay, and then an example of that would be if I had x squared minus 6x plus 5. Well, negative 5 and negative 1 would work for this. This would factor to x minus 5 times x minus 1. This is just where you find the two numbers that multiply to c and add to b. Okay, a trinomial where a is greater than 1, that would be ax squared plus bx plus c. And that is where you may have to use slip and slide. So if you have something like 2x squared plus 15x minus 77, that's a pretty big number, but it still works. You'll have to use slip and slide for that. And this one factors to 2x minus 7 times x plus 11. And so if you want to put in your notes, you would want slip and slide. And that's our method where we'd steal A, give it to C. Now you may also want to try grouping. And so that's when you have 4 terms. So one example of that would be something like this, where you have x to the third minus 2x squared plus 6x minus 12. And that's where you would group the first 2 terms and the last 2 terms. You pull out their GCF, so you have x squared for the first 2. You're left with x minus 2. And then we have 6 for the GCF of the second 2 terms, plus 6 times x minus 2. Now they have a common factor, so this would factor to x squared plus 6 times x minus 2. And for this one, that's as far as we can go because we don't have a difference of squares there. Okay, so that's your little factoring guide. Thank you for watching. I hope you have a great rest of your day.